In this video, I'm going to be talking about the entropy. Well, first of all, let's define the entropy. What is the entropy? There are many definitions of the entropy, and one way to define the entropy is as the average level of information associated with the possible outcomes of a random variable. Okay, so this might be a little bit confusing, but hopefully this would be cleared up after giving you an example. But first of all, let me write down again this definition because it's important. So one way to define the entropy is to define it as the average level of information associated with the possible outcomes of a random variable x. This is the definition. Now, to understand the concept of entropy, I'm going to give you an example. So let's say that I'm put in a situation where I'm going out tomorrow and I want to know what to wear. Should I wear a t-shirt or a coat? Of course, I'd wear a t-shirt if it's hot, if the temperature is hot, and a coat if the temperature is cold, right? So this means that my random variable here is t, which can either be hot or cold, right? Now the problem is that tomorrow I'm going out at 6 a.m. This is the time window or the time scale. So I'm going out at 6 a.m. This is when I would go out of my house, and the temperature starts to rise only after 10 a.m. So this means that in this window of time it's impossible for me to know whether the temperature would be hot or cold, right? So for this reason I use a phone application that gives me this information about t. So it tells me whether tomorrow is going to be hot or cold. Now my goal is to evaluate the level of information given by this application. So for that I would consider myself in different geographical locations. So the first geographical location would be in the North Pole. Now, in the North Pole, if I'm in the North Pole, in your opinion, would I need this application to decide whether I should wear a t-shirt or a coat? Well, the answer is obviously no, because the probability for the temperature to be cold is equal to 1, so I already know that. And the probability for the temperature to be hot is equal to 0, right? So this means that the level of information or the entropy of the information given about the temperature is equal to 0. So this is the average level of information. It's 0 because it's a useless information. I don't need that, right? So the same thing would be true if I'm, for example, in a deserted area in Middle Africa, for example. The temperature would always be hot, so I'm not going to use this information given by this application to decide what to wear. I would directly wear a t-shirt, right? But now, let's say that I'm in another country, for example, Russia. And in Russia, most of the time it's cold, so the probability for the temperature to be cold is equal to, say, 0.9, and the probability for the temperature to be hot based on that is just 0.1, right? So in that case, the entropy increases a little bit because, you know, the information is not completely useless. It's kind of useful. So in that case, the entropy would be close to 0.14. So it's not 0. It's close to 0, but it's not 0. So it's somewhat useful. There is some level of information associated with this random variable temperature. But now let's say that I am in another country where it's hard to know about the temperature. For example, my country, Morocco. In Morocco, it's difficult to know what the temperature would be. Would it be hot or cold? So in that case, the probability for the temperature to be hot is 50%, 0.5. Similarly, for cold, it would be 0.5. So in that case, it's extremely hard for me to make my decision, right? I can't know what to wear. It's really hard for me to make a good decision, okay? Because I have here 50% chance for the temperature to be hot, and again 50% chance for the temperature to be cold. So this means that I really need this information about the temperature. In that case, the entropy of the temperature, the random variable temperature, would be 1. This is the maximum value that the entropy can take. In fact, the entropy is a value that is between 0 and 1. So this is the most useless information, and this is the most useful level of information. So in that case, the level of information is at maximum, so it's 1, right? So hopefully this gives you a good idea about the entropy in case of course, of information theory. Now that we understood the concept, I would give you the formula for the entropy. So the entropy of a given random variable x, such that x has many outcomes, x0, x1, x2, etc. until xn minus 1. So this means that n is the number of possible outcomes, right? So in that case, n was equal to 2, because I had just 2 possible outcomes. So in that case, if I have many possible outcomes, this is how to compute the entropy. So I need to take the summation of probabilities of each outcome. This is the first outcome, or rather the 8th outcome, right? Multiplied by the second log of the same probability. And I should sum up all of these values from I equal to 0 to n minus 1 for all outcomes. And of course, we should not forget the minus here, because the log of a value that is between 0 and 1 is always smaller or equal than 0. So to get positive values for the entropy, we need to multiply here by minus 1. So this is one way to define, the formula of the entropy is of course always the same, whether we are talking about the information theory or in physics, but its interpretation may be different. So in our case, the interpretation was the level of information. There are some other cases where the interpretation can be different. For example, in the case for people who know about the decision tree, they use the entropy to evaluate the level of impurity of a given node or a leaf. So the interpretation of this entropy that I'm talking about can be different from one application to another, but the formula is always the same.